Okay, so in this lesson we're going to use the quadratic formula to solve quadratic equations. Now, in a previous lesson, you solved quadratic equations by factoring, but remember, not every quadratic equation can be solved by factoring, so we're going to use quadratic formula. The quadratic formula can be used with all quadratic equations. Now, the derivation of the quadratic formula we're not going to do in this lesson. It does require something called completing the square, which we're not going to discuss. So that's why we're not going to derive the quadratic formula. So I'm just going to go ahead and give you the quadratic formula. And so just keep in mind that when using quadratic formula, you are solving an equation of this type: ax squared plus bx plus c equals 0, and a cannot equal 0. So notice this is a quadratic equation, x squared, and it is in standard form. So remember the word standard form. So just like when you solved a quadratic equation by factoring, you had to make sure it was in standard form. Okay, so keep in mind that a cannot equal 0, because if a was 0, 0 times x squared is 0, and you would no longer have a quadratic equation, you would have a linear equation. All right, so that's why a cannot equal 0. B can be 0, c can be 0, but a can never be 0, otherwise it would no longer be a quadratic equation. All right, and here's what the formula is. So your variable is x in this case, so you're going to say x equal the opposite of b, Now keep in mind that a, when we talk about the letters in here, the coefficient of x squared is a, the coefficient of x is b, and your constant is c. So those are the numbers that you're going to use into the quadratic formula. So as you read this, it's read as the opposite of b plus or minus the square root of b squared minus 4ac. So b squared minus 4ac is the radicand. It is under the radical. And b squared minus 4ac is also called the discriminant. And we're going to talk about the discriminant in a little while. But it's also called the discriminant. So all of this, though, all of this is being divided by 2 times a. So this is your quadratic formula. So make sure you memorize this quadratic formula. So the opposite of b plus or minus the square root of, and your radicand is discriminant, which is b squared minus 4ac, all over 2 times a. All right, so let's go ahead and solve. And we're going to solve this by using the quadratic formula. Solve using the quadratic formula. Okay, so number 1, we have 4x squared plus 11x minus 20 equals 0. All right, so we have this quadratic equation. It is a quadratic equation. Notice the x squared. It is in standard form. You always make sure it's in standard form before you plug numbers back into a, b, and c. All right, now the first thing you want to do, first step, and this is on Canvas, the first step is to make sure you get it in standard form. It is. Then you're going to identify the letters a, b, and c. Once you identify the letters a, b, and c, you're going to plug those into the quadratic formula. Okay, so a is, remember, the a is the coefficient of x squared, so a in this case is 4. B is the coefficient of x. In this case, b is 11, positive 11. And c is your constant. In this case, it's a negative 20, not a 20. Make sure you keep the sign. It's a negative 20. So that's your a, b, and c. So now we're going to plug it back into the formula. So we get x equal the opposite of b. So if b is 11, then the opposite of 11 is negative 11. So the opposite of b. So negative b is 11, so you get negative 11. plus or minus the square root of, and for right now, just go ahead and plug in these numbers. Don't do anything else. Just plug them in, and keep in mind that when you square b, if b is positive, if b is negative, if b is positive, or if b is negative, b squared is always going to be positive because b times b, a positive times a positive is a positive, a negative times a negative is a negative. If b is 0, then 0 squared will be 0. All right, but the point is that b squared is never negative. It will never, ever, ever be negative because you're squaring a number. So when you square a number, when you square b, it means b times b. If b is positive, a positive times a positive is a positive. If b is negative, a negative times a negative is a positive. All right, so in this case, b is 11, so I'm put that in parentheses. Always put in parentheses, it does help. So 11 squared minus 4ac. Notice I'm putting all those in parentheses. A is 4, and c is negative 20. All over, it's negative 20. All over 2 times a in this case is 4. All right, so all you do right off is just plug in your numbers. All right, now go ahead and simplify these. So step 3 is to simplify the numbers within the quadratic formula. So negative 11 plus or minus. All right, so let's go ahead and simplify 11 squared. 11 squared means 11 times 11. Use your calculator if you don't know what 11 times 11 is. So you're going to say 11 squared is 121. Okay, now right here, think about this before you go on. Remember, subtracting 4 right here. Remember in the previous course, so change subtraction to addition, so that means add the opposite. So this is really, when you change addition, this is a negative 4. So a negative times a positive times a negative. So a negative times a positive is a negative, and negative times a negative is a positive. So this is going to be a plus symbol. And then you're going to say 4 times 20 equal 320. So you get 121 plus 320 all over 2 times 4, which is 8. All right, so then I get negative 11, still simplified, plus or minus the square root of. All right, 121 plus 320 is 441, all over 8. All right, so that's where I'm at. Now, don't leave your answer like this, because remember, step 4 says to simplify the radical, and then simplify and reduce or simplify to get the final answer. Okay, so what I would do first is let's determine if this right here is a rational number or an irrational number. Okay, so remember, rational or irrational. If it's rational, you want to write it a certain way. If it's irrational, you're going to write it a different way. All right, so rational, irrational. So this right here is going to be a rational number. Remember, we talked about rational number in the previous lesson. It's going to be a rational number if, when I take the square root of 441, I'm going to get a whole number. Now, that's going to mean that 441 is a perfect square when that happens. So, for example, let's kind of review this. Remember, 9 is a perfect square. So when I take the square root of 9, I'm going to get a whole number 3. 16 is a perfect square. So when I take the square root of 16, I'm going to get a whole number 4. 64 is a perfect square. When I take the square root of 64, I get 8. 100 is a perfect square. When I take the square root of 100, I get 10. 441 is a perfect square, because when I take the square root of 441, use your calculator. When I take the square root of 441, square roots 441, I get a whole number 21. So 441 is a perfect square. So when I take the square root, this becomes just 21 over 8. So this is a rational number. Now, since this is a rational number, since this no longer has a square root, so it's a rational number, then you want to write it as 2 rational numbers. So you're going to say negative 11 plus 21 over 8, and then negative 11 minus 21 over 8. And then negative 11 plus 21 is a positive 10 over 8, which reduced is 5/4. Over here, that's going to be negative 32 over 8, which reduced. Now don't leave it as negative 32 over 8 because you know that that's exactly negative 4. All right, so there are your solutions. So your solutions are on the blank, you would put x equal 5/4, comma, x equal negative 4. Okay? All right, so notice again that the discriminant is positive. The discriminant is positive, greater than 0, positive. So you ended up with two real solutions. Two real solutions. Okay, so your solutions were real numbers. In particular, though, the discriminant is equal to a perfect square. Since it's equal to a perfect square, when I take the square root, I get a whole number. So this is going to be a rational number. So I get two rational solutions. So not only, so knowing that the discriminant is positive, I get two real solutions. But since there are two real solutions, I'm going to either get rational or irrational. Rational versus irrational. Since this is a perfect square, it's rational. So that's what this says. Okay? All right. But if all they ask you is to solve the quadratic equation using quadratic formula, that is all you need to do. You don't have to worry about the discriminant, but the discriminant it allows you to discriminate the type of solutions and the number of solutions that you'll get. So basically, let me just show you this. So basically, b squared minus 4ac is called the discriminant. It tells you how many solutions and the type of solutions the quadratic equation will have. Okay, how many and the type. So it discriminates between how many solutions and the type of solutions this quadratic equation will have. So since the discriminant was positive, I'm going to end up with two real solutions. Two different real solutions. In particular, since the discriminant was a perfect square, that's where you say rational or irrational. Since a perfect square, these two real solutions are rational solutions. That's how it looks. Okay. So in another lesson, we're going to do one where the discriminant is not a perfect square. In that case, you're going to get an irrational number, and then you're going to write it differently. It won't look like this. It'll look a little bit different. All right, let's look at another example. So suppose we had x squared, this would be number 2, x squared equal 5x plus 24. So we have this quadratic equation. So remember, the first thing you got to do is put this in standard form. So let's bring every term to the left side. So when you do that, I'm going to get x squared minus 5x minus 24 equals 0. All right, so once you put it in standard form, remember the second step is to determine a, b, and c, and then plug it back into the quadratic formula. So a in this case is the coefficient of x squared, so that's 1. B is the coefficient of x, so that's negative 5, not 5, negative 5. It's whatever you multiply the variable x by. And c is your constant, which in this case is a negative 24. If any of these is incorrect and you do all this work, you're actually solving for a different quadratic equation, not this one. So make sure you're solving the correct quadratic equation. Now, once you get a, b, and c, you plug it back into the formula. Remember, the formula is this: x equals the opposite of b. It helps if you keep writing the quadratic formula. It helps you to remember it. Plus or minus the square root of, and then remember your discriminant is the radicand. So b squared minus 4ac, all that's being divided by 2a. All right, now, remember this means the opposite of b. Well, b is negative 5. b is negative 5. So in a previous course, you learned about this, the opposite of a negative 5. That's what this looks like. The opposite of b, the opposite of b. Since b is negative 5, this is what it looks like. So the opposite of negative 5 is a positive 5. So that's going to go here. So get x equal the opposite of b. So b is negative 5. The opposite of negative 5 is positive 5. Plus or minus the square root of, okay, b squared. Remember, put that in parentheses. And remember, if b is positive or if b is negative, this is always going to be positive regardless. Now, if b is 0, it's going to be 0, but it's never going to be negative. So I get negative 5 squared just like this. That's b. Minus 4 times a is 1, times c is negative 24. All over 2 times a is 1. All right, so the first step is once you determine a, b, and c, then you go plug it back in just like this. Now go ahead and simplify as much as you can. So 5 plus or minus the square root of negative 5 squared, remember, means negative 5 times negative 5. So use your calculator if you don't know what that negative 5 times negative 5 is, a positive 25. But be careful when if you're not using parentheses, which you should, you're going to say this. You're going to say negative 5 squared, and you're going to get this, and you're going to put negative 25 down there, and you're not thinking, because we just talked about the fact that b squared should always be positive. So the reason why you have that negative here is because you did not put negative 5 in parentheses. So you're going to say parentheses negative 5, close parentheses, then you're going to square it. Then you're going to square it just like this, and then press equal, and you get positive 25. So that's 25. All right, remember what we just did to do the same thing for the next part. A negative times a positive times a negative is a positive. And they're going to say 4 times 1 is 4 times 24. So 4 times 24 equal 96. All over 2 times 1 is 2. Still simplifying some more. You're going to say 5 plus or minus the square root of. Okay, then you can say 96. 96 plus 25 equal 121 over 2. Now at this point, now notice that the discriminant is positive, so you're going to get two real solutions. So you're going to get two answers. Well, two different solutions. But in particular, though, notice that 121 is a perfect square. And you know that because when I take the square root of 121, I get a whole number back. So I get 11. So that means this. So you get 5 plus or minus, and that's just 11 over 2. So notice the square's no longer there. So that means you're going to get two. Not only are those two real solutions, but they're rational. So since they're rational, you're going to split it up like this, just like we did the other one. You're going to say 5 plus 11 over 2, and then 5 minus 11 over 2. And so you're going to get x to be 5 plus 11, 16 over 2, which is 8. Don't leave it at 16 over 2. You're supposed to know that 16 over 2 is 8. The other one, you're going to say 5 minus 11, which is a negative 6 over 2. And so negative 6 over 2 is a negative 3. So those are your two solutions. So x equal 8, comma, x equal negative 3. All right, so that was number 2. All right, let's look at number 3. So number 3, you're going to have 3n squared minus 5n equal 8. So 3n squared minus 5n equal 8. Okay, so you have this quadratic equation. You want to use the quadratic formula. So you got to first of all make sure it's in standard form. So let's bring the 8 to the other side. So we get 3n squared minus 5n minus 8 equal 0. All right, now at this point, remember that's step 1. So step 1 was to make sure it was in standard form. So that was step 1. So remember it said this. It said simplify the problem to get the problem in the form ax squared plus bx plus equals 0. So we brought everything to one side. Then the next step is to determine a, b, and c. So a, remember, is a coefficient of n squared in this case. Your variable is n this time. So that's 3. B is a coefficient of n, so that's negative 5. And C is your constant, that's negative 8. Again, make sure that A, B, and C are correct, because if you use wrong A, B, and C, then you're no longer solving this quadratic equation, but you're solving a different quadratic equation, which is not what you wanted to solve. Once you find A, B, and C, then you plug it back into the formula. Now remember, the formula we had x equal. That's because we're using the variable x. So the variable here is n, so you're going to say n equals this time. N equals, and again, the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. And you just plug it back in. So remember, this means the opposite of b. Well, b is negative 5, so the opposite of a negative 5, remember, is a positive 5. So that'll be a 5 here. Plus or minus the square root of b squared. Well, b is negative 5, so I'm going to put that in parentheses. I'm going to square it. Minus 4 times a, which is 3, times c, which is negative 8, all over 2 times a, which is 3. So the first step was to plug everything back into this quadratic formula. Now let's simplify the numbers that are in the quadratic formula. So we get 5 plus and minus the square root of negative 5 squared means 25, positive 25. A negative times a negative is a positive. 4 times 3 times 8, so 4 times 3 times 8 equals 96, all over 6. So I get 25 plus or minus the square root of, okay, 96 plus 25 is 121 again, all over 6. And then again, at this point, since the discriminant is positive, we're going to get 2 real solutions. In particular, though, remember 121 is a perfect square, because when I take the square root of that, 121, I get 11. So in particular, we know that there are 2 real solutions, but those 2 real solutions are actually rational solutions. Since the discriminant was a real number, so I'm going to get 11 over, so 25 plus or minus 11 over 6, so the square root is no longer there. So I'm going to split into 2 parts. I'm going to say 25 plus 11 over 6, and then 25 minus 11 over 6. 25 plus 11 is 36 over 6, which is just 6. 25 minus 11 is going to be 14 over 6, which reduced is 7/3, it looks like. All right, so 25 minus 11 is 14, and 14 divided by 6 reduced to 7/3. And so your solution, you're going to say n equal in the blank. You can say n equal 6, comma, n equal 7/3. Okay? All right, number 4. All right, suppose we had this one. All right, suppose we had this one. Number 4. We had x squared minus 2x plus 1 equal 0. So x squared minus 2x plus 1 equals 0. All right, so it's already in standard form of this quadratic equation. So then you got to determine a, b, and c. So a in this case is a coefficient of x squared, so that's 1. B is a coefficient of x, so that's negative 2. And c is a positive 1. And then once you determine a, b, and c, you plug it back into the formula. So you get, remember the formula is x equal the opposite of b plus or minus the square root of your discriminant, b squared minus 4ac, all over 2a. All right, let's plug it back in. So the opposite of b, so b is negative 2, so that means the opposite of negative 2, which is positive 2. I get 2 plus or minus the square root of, remember for b, make sure you put in parentheses. So negative 2 is b, I'm squaring it, minus 4 times A is 1, times C, which is 1, all over 2 times A, and A is 1. All you do is just plug back into the formula the values of A, B, and C. So I get 2 plus or minus the square root of, let's simplify, negative 2 squared. Negative 2 squared means positive 4. Okay, a negative times a positive is a negative. So 4 times 1 is 4. So I get 4 minus 4 this time, all over 2. Well, 4 minus 4 is 0. So I get 2 plus or minus the square root of 0 over 2. Now, 0 is, okay, so remember we talked a while ago that if the discriminant is positive, you're going to get 2 real solutions. Well, notice the discriminant is 0 this time. So since the discriminant is 0, when I take the square root of 0, that's just 0. And so I get 2 plus or minus 0 divided by 2, just like this. But remember, 2 plus 0 and 2 minus 0 are the same thing. 2 plus 0 is 2. 2 minus 0 is also 2. So basically this right here is just 0. And so you get 2 over 2, which is 1. Now notice this time, in the previous 2, there were two real solutions. Here, since the discriminant is 0, you only get 1 real solution. 1 real solution. Alright, so far, and this is on Canvas, but the first 2 problems said that if the discriminant is positive, you're going to get 2 real solutions. They're different solutions. They're not the same solution. If the discriminant is equal to 0, you get 1 solution. Now it's called repeated because, and the reason it's called repeated was because when I came to this step here, I could have said 2 plus 0 over 2, 2 minus 0 over 2. And so, just like we did a while ago, so we get 2 over 2, which is 1, 2 over 2, which is 1. So you get 2 repeated solutions. So it's called a double root, but really we only list it once. So in the blank, you're just going to say x equal 1. So that's why it's called 2 repeated, as a repeated solution, a double root, because of this. 2 plus 0, 2 minus 0, just like we did in the previous problem. Okay, but it just turns out that these 2 numbers here are the same, so it's called a double root. So 2 solutions, a double solution, but you only listed once. Okay, and then finally number 5, let's suppose we had x squared minus 8 equal negative 2x. X squared minus 8 equal negative 2x. Alright, well, let's put it in standard form, and let's put it in descending order. So I'm going to get x squared plus 2x minus 8 equals 0. So x squared plus 2x minus 8 equal 0. Alright, so then we determine a, b, and c. A is coefficient of x squared, so that's 1. B is a coefficient of x, so that's a positive 2. And c is your constant, so that's negative 8. Plug it back into the formula. Remember, your formula is this: x equals the opposite of b, plus or minus, and then your discriminant goes under the radical, so that's your radicand, b squared minus 4ac, all over 2 times a. Alright, now the opposite of b. If b is 2, then the opposite of 2 is a negative 2. So that's negative 2. Plus or minus the square root of, again, put that in parentheses. So you'll notice that every time I plug in for B, A, and C into the discriminant, I'm putting parentheses. So 2 squared minus 4 times A is 1, times C, which is negative 8, all over 2 times A is 1. So let's simplify as much as possible. I get negative 2 plus or minus the square root of 2 squared is 4. A negative times a positive times a negative is a positive. 4 times 1 times 8 is 32, all over 2. So I get negative 2 plus or minus the square root of 36, all over 2. So notice the discriminant is 36. your discriminant is 36. So since that's bigger than 0, that means 2 real solutions. So I'm going to get 2 real solutions. In particular, though, the discriminant is a perfect square. So that's a perfect square. So since it's a perfect square, what that means, perfect square, what that means is that these real solutions are rational. They are going to be rational solutions. So what that means also is that when I simplify the square root of 36, I get this, plus or minus 6 over 6. So I no longer have a square root. So I'm going to get the rational solutions. And so I'll break it down like this. So I get negative 2 plus 6 over 6, negative 2 minus 6 over 6. Now negative 2 plus 6 is 4, so I get 4 6, which reduced is 2 thirds. Over here, negative 6 and a negative 2 is a negative 8 divided by 6. So reduced, I get negative 4 thirds. So those are your 2 solutions. So notice they're rational numbers. So I get x equal 2 thirds, and then x equal a negative 4 thirds. So that's your solutions. Okay, now in the next lesson, what's going to happen, see, when we did these 5 problems, the discriminant was a positive number or 0. And if the discriminant was positive, you'll notice that if you go back, they were all perfect squares. So in the next lesson, what's going to happen is that we're going to do problems where the discriminant is not a perfect square. So in that case, it's not going to be rational, it's going to be irrational, and you want to see how we're going to write the answer in that case. Okay? The answer will be written a little bit differently. All right, so that's the end of part A.